Hello and welcome. Today is 2nd December 2020 and we are discussing rational numbers. Today we will learn about commutative property of rational numbers, and we will learn commutative property in the context of whole numbers, integers and rational numbers. Let's get started. So let's evaluate for whole numbers how does the commutative property apply across the four operations. What are four operations? Four operations are simply addition, subtraction, multiplication and division. So first we will explore addition. Now what are whole numbers? We know whole numbers is simply a collection of numbers that start with the number 0. Then we have number 1, number 2, number 3 and then dot 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 all the way to plus infinity. It is this collection of numbers we call them whole numbers. Now what we are going to do is we are going to arbitrarily take any two whole numbers. So let's say the number 2 and let's take another number 5. And first let's explore for addition how does commutative property apply. So what happens when we add 2 and 5? So it will be 2 plus 5, which is going to be simply 7. And now we are going to change the numbers, or I should say we are going to switch the order. So instead of doing 2 plus 5, we are going to do 5 plus 2. Well, what is the answer of 5 plus 2? Well, this is again 7. So in both cases, we get 7. So even though we have switched the numbers, the order doesn't seem to matter because in both cases, we get the same result. Let's take another example. Maybe this time let's take 3 and 10. So let's say we have the number 3 and let's add the number 10 to it. So 3 plus 10 here is 13 and let's do 10 plus 3, which is again 13. So these are some random examples, but we notice that for whole numbers that a plus b, where a and b are two whole numbers, this will be always equal to b plus a. That means it doesn't matter the order, the sum is going to be always same. And so we say that for whole numbers, addition is commutative. Now let's explore subtraction. So these are our whole numbers. So let's take the number 2 again and let's subtract 5 from it. So now we are evaluating subtraction operation. So what is 2 minus 5? 2 minus 5 is minus 3. What is 5 minus 2? So here we are switching the numbers. 5 minus 2 is simply 3. So we notice that in this case, so 2 minus 5 is not equal to 5 minus 2. Let's take one more example. Say the number 3 minus 10. This will be minus 7. And 10 minus 3 is just going to be plus 7. Again, the same thing, that 3 minus 10 not equal to 10 minus 3. So what we see here is for subtraction, a minus b, again where a and b are two whole numbers, is not equal to b minus a. That is, the order is important. So we say that for whole numbers, subtraction is not commutative. Let's move on to multiplication. Now we are exploring multiplication of two whole numbers. So let's take the number 2 again and then multiply this with 5. 2 times 5 is 10. What is 5 times 2? 5 times 2 is also 10. Let's take the number 0 and multiply this by maybe the number 7. So these are two whole numbers. So I'm randomly writing some examples. So 0 times 7 is actually 0. What is 7 times 0? We have switched the numbers. Well, 7 times 0 is again 0. How about 5 times 11? Well, 5 times 11 is 55. And what is 11 times 5? Well, this will be again 55. So it appears, and this is true, that when we multiply two whole numbers, a times b, where a and b are two whole numbers, they will always be equal to b times a. So we say that for whole numbers, multiplication is commutative. Let's discuss the division. So again, let's take some arbitrary whole numbers. So let's say 6 divided by 2. So when we divide 6 by 2, what do we get? Well, we get the number 3. They cancel out, right? Now let's switch the numbers, and what do we get then? So we have 2 divided by 6. So in this case, we get 1 over 3. So is 6 by 2 equal to 2 by 6? Answer is they are not. So similarly, if we were to do, let's say, maybe 5 by 7, right? So we cannot simplify, we'll get a decimal number here. But we see clearly 5 by 7 is not same as 7 over 5. They are not equal, because this will be 0 point something, right, when we do the division, and this will be 1 point something. So clearly, these two will not be equal. So we say that when it comes to division, we notice that A divided by B is not equal to B divided by A. The order in which the numbers appear is important, just as it was for subtraction. So we say for whole numbers that division is not commutative. Now let's move on to integers. We know that integers are simply a collection of numbers that start from minus infinity and they go dot dot dot. Then we have these negative numbers, minus 2, minus 1. We have gone from minus infinity to minus 1. Then we have the number 0, and then 1, 2, then dot 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 all the way to plus infinity. It is this collection of numbers, we call them integers. Now let's take random examples and see how it applies. So we will again understand commutativity for integers for 4 operations: addition, subtraction, multiplication, and division. So let's start with addition. So let's take 2 integers. Let's take one negative integer, minus 2, and let's add a positive integer, maybe 5. So what happens when we do this? Well, this is simply minus 2 plus 5, which will be 3. So what happens when we actually switch the numbers? So we will have 5 plus minus 2, which will be simply 5 minus 2, which is going to be 3 again. So we see they both are equal. This time, for the second example, let's take 2 negative integers. So maybe we will take minus 10, the first integer, plus minus maybe 3. So minus 10 minus 3 is minus 13. And let's go ahead and switch the numbers. So now we have minus 3 plus minus 10. Well, this will be minus 3 minus 10, which is minus 13. And if we were to take 2 positive numbers, we will see that it will be the same as the whole numbers when we were adding 2 whole numbers. So what we see here is that whenever we have 2 integers, that A plus B is always going to be equal to B plus A. So we say that for integers, addition is commutative. Now let's explore subtraction. So let's take 2 whole numbers again, 2 integers I should say again. So let's say we take minus 2, and our second integer is a negative integer. So let's say minus 2 minus 10. So let's do this operation, see what we get. So this will be minus 2, minus minus will become plus, it will be plus 10. So 10 minus 2 is simply 8. Let's switch the numbers. So this time we have minus 10 here, minus minus 2. So this will be minus 10, minus minus will become plus, plus 2, minus 10 plus 2 is minus 8. So we see these two are not equal, right? Let's take a look at our second example. This time let's take one negative integer and one positive integer. So maybe we can do, say, minus 3 minus, and our second integer is 7. So this will be simply minus 3 minus 7, which is minus 10. Let's switch the numbers, and now we have 7 minus minus 3. So this will be 7, minus minus will become plus 3. This will be plus 10. So again, we see they are not equal. So in other words, A minus B is not equal to B minus A. So we say that for integers, subtraction is not commutative. All right, now let's discuss multiplication. So our two integers here are, let's say, minus 2. Let's multiply this by minus 5. So what happens? So minus minus will become plus, and 2 times 5, so this will become 2 times 5, which is simply 10. And if you were to switch the numbers, that is, write minus 5 first, minus 5 times minus 2 will be simply 5 times 2, or it will be 10. We get the same results. All right, this time let's take a negative integer and a positive integer. So maybe we have minus 5, let's say, and let's multiply this by the number 10. So here we get minus times plus is negative, and this will be 5 times 10 is minus 50, right? Let's go ahead and change up the numbers. And now let's explore 10 times minus 5. 10 times minus 5 is again minus 50. So we notice that when it comes to multiplication, that A times B is always equal to B times A, where A, B are two integers. So we say for integers that multiplication is commutative. Let's explore now the division operation. So let's take two integers. So let's say we have minus 6 as our first integer. We divide this by, let's say, minus 2. So these are two integers. What do we get here? This will be simply 6 divided by 2, or it will be 3. Right? Now let's switch the numbers, and let's do minus 2 divided by minus 6. So minus minus will again cancel out. We are going to be left with 2 by 6, which will be 1 over 3. So we see these two are not equal. These two are not the same, right? So similarly, we will see that if we have maybe one negative, one positive, let's say we have maybe the number 10 divided by minus 2. Well, in this case, this will give us minus 5. But what happens when we change the order? That is, we do minus 2 divided by 10. What do we get here? We will get minus 1 by 5. So again, these two are not equal. So we realize that A divided by B is not equal to B divided by A. So where A, B are two integers. So we say that for integers, division is not commutative. Now let's move on to rational numbers. We know rational numbers are simply numbers that can be written in the form of P by Q, where P and Q are both integers, but Q is not equal to 0. So let's take two rational numbers and explore for addition what happens. So if we have, let's say, 2 by 3 and plus, let's say, 1 by 4. So I'm arbitrarily writing two rational numbers. So here we will first, in order for us to add, we are going to make the denominator same. So we will write both of them in terms of 12. So this will be 3 4s are 12. So 2 times 4 will be 8. Plus 1 times 3 is 12. 3 times 1 is 3. Or this will be 11 over 12. Now let's change them up. So we have 1 by 4 plus 2 by 3. So here we have simply switched the order of the numbers. And here again, the LCM will be 12. And this will be 3 plus 8, or 11 by 12. So we will always see that when we add two integers, that A plus B will be always equal to B plus A, where A, B are two rational numbers. And so we say that for rational numbers, addition is commutative. What about subtraction? So our two numbers, now we're evaluating subtraction. So 2 by 3 minus 1 by 4. So let's explore this. So here we know the denominator is 12, and this will be 8 minus 3, which is simply going to be 5 over 12. Let's change it up and see what happens. So we have 1 over 4 minus 2 over 3. So denominator is 12, and this will be 3 minus 8, which will be minus 5 by 12. And these two are not equal. So we see that for any, I should say, yes, these are two, A and B are two rational numbers. So A minus B is not equal to B minus A. And hence, for rational numbers, subtraction is not commutative. Let's move on to multiplication. So we have our same two rational numbers, 2 by 3. Let's multiply this by 1 by 4. So what happens here? So we will simply have 2 times 1 by 3 times 4. And here this will be like that. And then we'll be left with 1 divided by 6. Now let's change them up. And now we have 1 over 4 times 2 over 3. So this will be 1 times 2 by 4 times 3. And this will be 2. So here we have 1 divided by 6 again. So they are equal. So we say that for all rational numbers, A times B will always be equal to B times A. That means multiplication is commutative. And finally, let's take a look at division. So we have 2 divided by 3. Let's do this divided by 1 over 4. So this will be 2 by 3 multiplied by this will change. So it will become 4 by 1, which will be 2 times 4 by 3 times 1. This will be 8 divided by 3. Now let's change the order. So we are having 1 over 4 divided by 2 by 3. So let's see what happens here. So we write 1 by 4 like this and multiply by, and now this switches. So this will be 3 by 2. This is a simple, the way we do division of two fractions. So in the numerator we have now 1 times 3. Denominator we have 4 times 2. So with 3 by 8. These two are not equal. So we say that A divided by B is not equal to B divided by A, where AB are two rational numbers. So we say that for rational numbers, division is not commutative. So I know this video has become a very long video, but let's quickly wrap it up. So what we see here is that for addition, it is always commutative. For subtraction, it is never commutative. For multiplication, just the same way as addition, it is always commutative. For division, this is like subtraction, it is never commutative.